So find the area inside r equals 10 sine theta, but outside r equals 2. Which one is which? The green one is r equals 10 sine theta. Not only the radius is bigger, that's because of the 10. 10 dictates how far r will go. But also it's shifted up. That is a circle that's standing on the floor. And then r equals 2 is a circle that's centered at 0. Radius is 2. We need to find this shaded area. So what we're going to do, we need to find this formula. First of all, write down the formula. Solution. The formula for the area is from alpha to beta. There is 1/2 in front. You can put it inside, but I always kind of remember it at the last moment somehow. 1/2 in front, square your input d theta. Not only we don't understand what to square, but we also don't understand where the angles are. Okay, the squaring part actually is kind of making sense that you do big one minus small one. So we're gonna square the green, no, actually we're gonna recolor it. We're gonna square this circle, right? Minus the smaller circle. So kind of I understand what to do with the piece inside. Let me know if that makes sense. It will be 1/2 integral, and then I will square the bigger function, and now we know which one is bigger, 10 sine theta. And it also makes sense, 10 radius is bigger. Minus r equals 2, so 2 squared d theta. Okay, I got that. From alpha to beta. And I even know how to integrate this. Again, it's going to be sine square. Sine square is done using double half angle formula. But what's hard is actually to find those stupid angles. Alpha and beta are not very clear. Alpha and beta are something like this. Where does this awkward object start? And then this is how the area was created in polar. Instead of doing rectangles, vertical or horizontal slices of rectangles, we are spinning. We're spinning from alpha to beta. This is how, imagine if the CAT scan would be have a circular motion. So I would do like this. This is the idea. Where does this awkward object start? From this point, then it goes around and ends at this point. So we need to find the angles for those 2 points. So spinning instead of covering with rectangles, because all polar equations have a spinning idea, circles. So to do that, we will set those 2 equations equal to each other. To find the angles, to find alpha and beta, let's write the system r equals 10 sine theta, r equals 2. They intersect each other at those points. So as always, we're just gonna try to solve the system. That is 2 equals 10 sine theta. We need to solve this trigonometric equation. Divide by 2. That will be 1 equals 5 sine theta. Well, actually divide by 5. That actually makes sense more to me. Divide by 5. Why did you not divide by 10 right away? 1 over 5 equals sine theta. That is my equation. That's a trigonometric equation. We need theta. Theta can come from the knowledge of inverse trigonometric functions, arc sine. So it's going to be arc sine, which I like to write down as sine minus 1, of 1/5. To find arc sine of 1/5, you ask the question, angle, sine of what angle gives you 1/5? I don't know. And since you don't know, just keep it as it is. You don't always have to know all this stuff. You can always plug it in at the end and figure it out later. Or use calculator. So that is only one angle. Where's the other one? Negative is an interesting idea. We're going to be using idea of pi. Pi is a shift. So this is the first point of intersection. Remember, inverse functions are not unique. So they sometimes give you several solutions. That means this gives you alpha and beta if you knew what these angles are. So to figure out the second angle, we're gonna do like this. We can see that they are different by pi. See? They're only different by pi. So if I found the first angle in blue, which is alpha equals arc sine of 1/5, how to find beta? Do you know? 180, which is pi minus whatever we found. And that's what we're going to be using. That's what we're going to be using here. But also, you know, actually, there is a nice answer for this angle. I just really don't want to go there because you don't have to. That's the beauty of it. You don't have to actually be specific about those things. So beta will be pi minus alpha. So pi minus arc sine from -1 over 1/5. Done. After this, we finish integral and just integrate. A is, don't forget 1/2 in front of the formula. That's the hard part. Don't lose the 1/2. 1/2 formula comes from the definition of the sector. Integral from, which one goes first? Pi minus stuff or the original? Original. Remember, it's from alpha to beta. Whoever comes first in the picture goes first. The object starts from this positive small angle, and then it goes back. So the other angle, by the definition, is actually this big. So either you find how huge it is, or you do pi minus the same one. That's what I did. I did pi minus the same angle using symmetry. So it's going to be original, and then pi minus original. R squared minus r squared. The big one, the big circle, 10 sine theta squared minus the small circle, 2 squared. Do theta. And you can finish integrating this. What do you think about this? And you can finish it. Remember, use substitution, double angle, and blah, blah, blah. I actually have the answer in front of me. It is approximately 72.8 units. It's area, right? So what's the unit? Unit squared. Good job. Remember, it's better to be positive. If on a test you give me negative area, maybe you just messed up with the order. Just change the order, you're fine. But remember, no negative areas, no negative arc lengths, and no negative volumes. We don't do that. What do you think about this? Not too bad. Kind of annoying, but not too bad.